Section 3.6, continuing page 24, we are going to sketch the graph of our function out based on the different attributes that we have found so far. So going back to the beginning, we had found x and y intercepts. So we found we had x-intercepts at positive 4 and negative 4. We also found a y-intercept at negative 48 over 9. Well, we also found that we had vertical asymptotes. Our vertical asymptotes were at positive 3 and negative 3. Okay, so I've drawn the information for my asymptotes and my intercepts. Also remember we had said that there was y-axis symmetry. So I know the left side of my graph will be a mirror image of the right side of my graph. So if I can get half of it, the mirror image will give me the other half. So we had looked at on the second parts where we found our derivatives that our function is increasing from negative infinity to negative 3. So it's increasing up to the first asymptote, then increasing from negative 3 to 0. So increasing and increasing. It was decreasing from 0 to 3 and decreasing from 3 to infinity. We also said it had a relative maximum at 0, negative 48. So I know I have a relative max right here. So it makes sense that my graph was increasing and decreasing, and that's a relative max. So it's going to go up something like a U shape here, kind of like a parabola but not a parabola. Well, we also found concavity. And we had said the concavity was positive before negative 3. Concavity was negative between negative 3 and 3, which matches if it's a downward shape curve. And concave up from 3 to infinity. We also said there were no points of inflection. So since there are no points of inflection, and I know my graph is going to be concave up, I actually also need to include my horizontal asymptote. I accidentally left it off. So if I include my horizontal asymptote, and I know it's concave up from negative infinity to negative 3, then intercept at negative 4, I can pretty much conclude my graph has to have a shape kind of like this. In the middle, we already said it's concave down where it was increasing and then decreasing. And on the right part, we said it was intercept at 4 and concave down, but it's also symmetric. So what's the mirror image of this? Well, it would be a graph coming down like this. So this will be our sketch. So we've just used our knowledge of precalculus and calculus to sketch this function, 3 times x squared minus 16 over 9 minus x squared, without using a calculator, simply using our calculus and algebra knowledge. So this is a way in which we can put everything together in order to create the sketch of a graph. All right, there's another example for section 3.6 provided in the notes that you can look through as an additional example if you like.